The modules described in this chapter provide a variety of specialized data types such as dates and times, fixed type arrays, heap queues, double-ended queues, and enumerations. Python also provides some built-in data types, in particular dictionary, list, set, and frozen set, and tuple. The str class is used to hold Unicode strings, and the bytes and byte array classes are used to hold binary data. The following modules are documented in this chapter: date time, basic date and time types, aware and native objects, constants, available types, common properties, determining if an object is aware or naive, time delta objects, examples of usage time delta, date objects, examples of usage date, date time objects, examples of usage date time, time objects, examples of usage time, tz info objects, time zone objects, strf time, string format time, and string strp time behavior, strf time and strp time format codes, technical detail, zone info IANA time zone support, using zone info, data sources, configuring the data sources, compile time configuration, environment configuration, runtime configuration. The zone info class, string representations, pickle serialization, functions, globals, exceptions and warnings, calendar, general calendar related functions, command line usage, collections, container data types, chain map objects, chain map examples and recipes, counter objects, DQ objects, DQ recipes, default dict object, default dict examples, named tuple factory function for tuples with named fields, ordered dict functions, ordered dict examples and recipes, user dict objects, user list object, user string object, collections.abc abstract base classes for containers, collections abstract base classes, collections abstract base classes, detailed description, examples and recipe, heap queue, heap queue algorithm, basic examples, priority queue implementation notes, theory, bisect array bisection algorithm, performance notes, searching sorted list, examples, array efficient array for of numeric values, weak references, weak reference object, example finalizer object, comparing finalizers with underscore underscore delete underscore underscore methods, types, dynamic type creation and names for built-in types, dynamic type creation, standard interpreter types, additional utility classes and functions, coroutine utility functions, copy, shallow and deep copy operations, pprint, data pretty printer, data pretty printer objects, example, rep r lib, alternate rep r implementation, rep r objects, subclassing rep r objects, enum, support for enumerations, module contains data types, supported underscore underscore dunder names, underscore underscore dunder names, utilities and decorators, nodes, graphlib, functionality to operate with graph like structures, exceptions. Next, date time, basic date and time types, lib slash datetime dot py. The date time module supplies classes for manipulating dates and times. While date and time arithmetic is supported, the focus of the implementation is on efficient attribute extraction for output formatting and manipulation. Tip: skip to format codecs. See also module calendar, general calendar related function, module time, time access and conversions, module zone info, concrete time zones representing the IANA time zone database, package date util, third party library with expanded time zone and parsing support, Package data date type, third party library that introduces distinct static types. To example, allow static type checkers to differentiate between naive and aware objects. Aware and naive objects. What are aware and naive objects? Date and time objects may be categorized as aware or naive, depending on whether or not they include time zone information. With sufficient knowledge of applicable algorithmic and political time adjustments such as time zone and daylight saving time information, an aware object can locate itself relative to other aware objects. An aware object represents a specific moment in time that is not open to interpretation. A naive object does not contain enough information to unambiguously locate itself relative to other date time objects. Whether a naive object represents coordinated universal time UTC local time or time in some other time zone is purely up to the program. Just like it is up to the program whether a particular number represents meters, miles, or mass. Naive objects are easy to understand and to work with at the cost of ignoring some aspects of reality. For applications requiring aware objects, datetime and time objects have an optional time zone information attribute tzinfo that can be set to an instance of a subclass of the abstract tzinfo class. These tzinfo objects capture information about the offset from UTC time, the time zone name, and whether daylight saving time is in effect. Only one concrete TZ info class, the time zone class, is supplied by the date time module. The time zone class can represent simple time zones with fixed offsets from UTC, such as UTC itself or North American EST and EDT time zones. Supporting time zones at deeper levels of detail is up to the application. The rules for time adjustment across the world are more political than rational, change frequently, and there is no standard suitable for every application aside from UTC. Constants. The datetime module exports the following constants. Datetime.mean year, the smallest year number allowed in a date or datetime object. Mean year is 1. The max year, the largest year allowed in a date or datetime object. Max year is 9999. Datetime.utc, alias for the UTC time zone singleton. Datetime.timezone.utc. Available types. Class datetime.date, an idealized naive date assuming the current Gregorian calendar always was and always will be in effect. Attributes year, month, and day. Class datetime.time, an idealized time independent of any particular day assuming that every day has exactly 24 into 60 into 60 seconds. There is no option of leap seconds here. Attributes hour, minute, second, microsecond, and tz info. Class datetime.datetime, a combination of a date and time. Attributes year, month, day, hour, minute, second, microsecond, and tz info. Class datetime.timedelta, a duration expressing the difference between two date time or datetime instances to microsecond resolution. Class datetime.tzinfo, an abstract base class for time zone information objects. These are used by the datetime and time classes to provide a customizable notion of time adjustment. For example, to account for time zone and or daylight saving time. Class datetime.timezone, a class that implements the tzinfo abstract base class as a fixed offset from the UTC. Objects of these types are immutable. Subclass relationships. Object time delta, tzinfo, time zone, time, date, date time. Common properties. Date, date time, time, and time zone types share these common features. Objects of these types are immutable. Immutable. Objects of these types are hashable, meaning that they can be used as dictionary keys. Objects of these types support efficient pickling via the pickle module, determining if an object is aware or naive. Objects of the date types are always naive. An object of type time and date time may be aware or naive. A date time object D is aware if both of the following hold. D.tzinfo is not none. D.tzinfo.utc offset D does not return none. Otherwise D is naive. A time object T is aware if both of the following holds. T.tzinfo is not none. T.tzinfo.utc offset none does not return none. Otherwise T is naive. The distinction between aware and naive doesn't apply to time delta objects. Time delta objects. A time delta object represents a duration, the difference between two dates or times. Class date time dot time delta. Days is equal to 0, seconds is equal to 0, microseconds is equal to 0, microseconds, milliseconds is equal to 0, minutes is equal to 0, hours is equal to 0, weeks is equal to 0. All arguments are optional and default to 0. Arguments may be integers or floats and may be positive or negative. Only days, seconds, and microseconds are stored internally. Arguments are converted to those units. A millisecond is converted to 1000 microseconds. A minute is converted to 60 seconds. An hour is converted to 3600 seconds. A week is converted to 7 days. And days, seconds, and microseconds are then normalized so that the representation is unique. 0 less than equal to microseconds less than equal to 1 0 0 0 0 0 0 0 less than equal to seconds less than 3600 into 24, the number of seconds in one day. Point minus 999,999,999 less than equal to days less than equal to 999,999. The following example illustrates how any arguments besides days, seconds, and microseconds are merged and normalized into those three resulting attributes. Data types. Date time. From date time, import time delta. Delta is equal to time delta. Days is equal to 50, seconds is equal to 27, microseconds is equal to 10, milliseconds is equal to 29000, minutes 5, hours 8, week 7. Print delta. Print delta. 64 days 80556 this. If any argument is a float and there are fractional microseconds, the fractional microseconds left over from all arguments are combined and their sum is rounded to the nearest microsecond using round half to even tiebreaker. If no argument is a float, the conversion in normalization processes are exact. No information is lost. If the normalized value of days lies outside the indicated range, overflow error is raised. Note the normalization of negative values may be surprising at first. For example, d is equal to microseconds minus 1. -186,399. Class attributes. Time delta dot mean, the most negative time delta object. Time delta this. Time delta dot max. For example, print time delta dot mean, comma, format. Time delta dot mean, comma, time delta dot max. Mean is equal to max is equal to this. Mean this days, max this days. Time delta the most positive time delta object. Time delta days is equal to this, hours minutes is equal to this. Time delta dot resolution, the smallest possible difference between non-equal time delta objects and time delta. Resolution is equal to time delta dot resolution, generate resolution 0000. Instance attributes read only. Days is equal to between this inclusive. Seconds is equal to 0 to this 86399 inclusive. Microseconds between 0 inclusive. Supported operations. Operation result. T1 is equal to T2 plus T3. Sum of T2 and T1. Afterwards T1 minus T2 is equal to T3. T1 minus T2 is equal to T3 and T1 minus T3 is equal to 2 are true. T1 is equal to T2 minus T3. Difference of T2 and T3. Afterwards T1 is equal to T2 minus T3 and T2 is equal to T1 plus T3. T1 is equal to T2 multiplied by I, or T1 is equal to I multiplied by T2. Delta multiplied by an integer. Afterwards T1 divided by I equal to T2 is true, provided I not equal to 0. In general, T1 into I is equal to T1 into I minus 1 plus T1 is true. T1 is equal to T2 into F, or T1 is equal to F into T2. Delta multiplied by a float. The result is rounded to the nearest multiple of time delta dot resolution using round half to even. F is equal to T2 by T3. Division 3 of overall duration T2 by interval unit T3 returns a float object. T1 is equal to T2 by F, or T1 is equal to T2 by I. Delta divided by float or an integer. The result is rounded to the nearest multiple of time delta resolution using round half to even. T1 is equal to T2 mod T2 divided by integer division I, or T1 is equal to T2 integer divided 3. The floor is computed and the remainder, if any, is thrown away. In the second case, an integer is returned. T1 is equal to T2 mod 3. The remainder is computed as a time delta object. Q, or quotient remainder, is equal to D mod T2 T1. Computes the quotient and remainder. Q is equal to T1 mod T1 integer divided T2, and R is equal to T1 mod T2. Q is the integer and R is a time delta object. Plus T1 returns a time delta object with the same value. Minus T1, time delta minus T1 days, minus T1 seconds, and minus T1 microsecond. ABST equivalent to plus T when T dot days is greater than equal to 1, and 2 minus T when T dot days less than 0. STRT, return a string in the form D days as H HMMSS dot UUU where D is the negative for negative. A wrap R returns a string representation of the time delta object as a constructor call with canonical attribute value. Notes: this is exact but may overflow. This is exact and cannot overflow. Division by 0 resists 0 division error. Minus time delta dot max is not representable as a time delta object. String representation of time delta objects are normalized similar to their internal representation. This leads to somewhat unusual result for negative time deltas. For example, print time delta hours equal to -5, -1 day, the expression T2 minus T3 will always be equal to the expression T2 plus minus T3 except when T3 is equal to time delta dot max. In that case, the former will produce a result while the latter will overflow. In addition to operations listed above, time delta objects support certain additions and subtractions with date and datetime objects. See below. Comparison of time delta objects are supported with some caveats. The comparisons equal and not equal always return a bool, no matter the type of the compared object. Print delta 2 not equal to delta 1. Seconds, okay, true. Delta 2 is equal to 5. Print delta 2 is false. For all other comparisons such as less than and greater than, when a time delta object is compared to an object of a different type error is raised. Delta 2 greater than delta 1. Delta 2 greater than delta 1 is true. Right? If in delta 2 greater than 5, let's see, print delta 2 greater than 5. Error. In Boolean context, a time delta object is considered to be true if and only if it is equal to time delta. Instance methods: time delta dot total seconds return the total number of seconds contained in the duration equivalent to td by divided by time delta seconds is equal to 1. For interval units other than seconds, use the division from directly. Example: td slash time delta microseconds is equal to 1. Note that for very large times intervals greater than 270 years on most platforms, this method will lose microsecond accuracy. Examples of usage: time delta. An additional example: components of another year and up to exactly 365 days. Date time. Time delta. Example: from date time, import date time delta. Year is equal to time delta days 360. The year time delta weeks is equal to 40 days. 84 hours is equal to 23 minutes. Year is equal to another year. That should be false. Why true? Mm, Wix 40. Year dot total seconds. Print dot total seconds. This one. Example of time delta arithmetic from 10 years. Year is equal to time delta, days is equal to 365, 10 years is equal to 10 into year. Print 10 years. 3650 days, right? 10 years dot days divided by 365, and 10 years dot days 10. 9 years is equal to 10 years minus year. Print 9 years print 9 years. Okay, 3 years is equal to 9 years divided by modulo 3. 3 years is equal to 9 years mod 3. Print 3 years. 3 years divided by this. Date objects. Thank you.